Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 9 from the June 2020, October 2020, C34, which is the old specification. This question here is about parametric equations, so it's now in P4. It's in the P4 specification of the new specifications now. So this question here is telling us that figure 3 shows the sketch of a curve which is called C, and it's given us the parametric equations which define that curve. So it's defined as x equals 1 minus 8 times cosine 2t and y equals 9 times sine t, and t is between 0 and pi over 2. That's kind of the range, the domain of this in terms of t. Then it says use parametric differentiation to find the value of dy dx at the point on C where x equals 5. So they want us to use parametric differentiation. Okay, they very clearly say use parametric differentiation because it is possible for us to change this into Cartesian form and then differentiate it. In fact, part B tells you to change it into Cartesian form. However, they very clearly here state use parametric differentiation. So here we don't really have that choice. We have to use parametric differentiation. Okay, so that's one thing. So to use parametric differentiation, basically we're going to use what's called the chain rule. So we want to find dy dx. They said find dy dx at the point on C where x equals 5. So we've got to find an expression for dy dx first. Now dy dx, if you're using parametric differentiation using the chain rule, is dy dt, because this is like in terms of t the third parameter. So dy dt multiplied by dt dx. That's the same thing as dy dx. The dt's cancel out. Okay, so now we know that y is equal to 9 times sine t. That's pretty simple to differentiate. Dy dx, well, the differential of sine of something is cosine of the same thing, so it's 9 times cosine of t. That's no problem. Then the next expression we have to differentiate is we're going to find the dt dx, but let's find dx dt first because that's easier, of course. So 1 minus 8 cosine 2t. Now I want to find dt dx, but making t the subject of this is going to be a big hassle. So what we're going to do is we're going to find dx dt and then use its reciprocal. So dx dt, now to differentiate 1 becomes 0. Minus 8 cosine 2t. Now minus 8 stays as it is because it's multiplying it, so it's minus 8 cosine 2t. Alright, the 1 goes because it's added to it. It's not multiplying it. So minus 8 cosine 2t. Now if you differentiate cosine 2t, you get minus sine 2t. And because there is a function inside this function, there's a 2t, it's not just t, it's 2t, you have to multiply by that 2. So you end up with getting, for dx dt, you end up getting, there's a minus and a minus is a plus, 2 times 8 is 16, so you're left with 16 times the sine of 2t. So that's using the chain rule here. Now we want to find dy dx. So dy dx is going to be dy dt, which is 9 times the cosine of t, multiplied by 1 over 16 times the sine of 2t. So we have an expression for dy dx. Dy dx therefore is 9 times the cosine of t over 16 times the sine of 2t. We can leave the answer like that if we want, and then we can continue to find what t is when x equals 5, because that's what we have to do. We need to substitute the value of t in here when x is 5, because at the point on C where x is 5, we've got to find what t is at that point and use the value of t to find dy dx. All right. However, I think I'm going to make it slightly easier by rewriting this using the double angle formula. We know the sine of 2 times an angle is equal to 2 times the sine of that same angle times the cosine of that same angle. So I can write this as 9 times cosine t over 16 times 2 sine t cosine t. And what happens is these cancel out. So I'm left with a more simple expression. Dy dx is equal to 9 over 32 times sine t. Okay, now it's for us to find out what what t is when x is 5. So we know that x equals 1 minus 8 times cosine 2t. So when x equals 5, you got 1 minus 8 times cosine 2t equals 5. Okay, so we're left with a negative 4 equals 8 cosine 2t. So we can say cosine 2t is equal to negative a half. So 2t is equal to inverse cosine of negative a half. So you have radian mode, inverse cosine of negative a half. I think the cosine of a half is 60 degrees, which is pi over 3. So this is going to be 2 pi over 3, I think. Yep, 2 pi over 3. So that's 2 pi over 3. Therefore, t is equal to, divide both sides by 2 pi over 3. So when x equals 5, t is equal to pi over 3. So therefore, we can find dy dx is equal to 9 over 32 times the sine of pi over 3. Okay, so we could even just put that in our calculator if you want to, but if you want to show the steps, no problem. That's 9 times 32. The sine of pi over 3, that's the sine of 6, that's root 3 over 2. Okay, that cancels, that gives you 16. So you're left with 9 over 16 times root 3. That's not rationalized, and the question wants it to be rationalized, of course. So we multiply both the top and bottom by root 3. So we're left with 9 root 3. 9 root 3 over 48. Is that 16? Yeah. 9 root 3 over 48. Is that right?